Hello, welcome to the walkthrough for Spullows, the design wizard for metallic expansion joints. Spullows is a fully customizable application that allows you to design different types of metallic expansion joints based on the 9th edition of EJMA standard with 2011 addenda. It also has the ASME standards included. Spullows also includes a provision to include the B31.3 standard as an optional requirement under customization. Before we get started with Spullows, we shall enlist the list of bellows types and standards that have been adhered to in this program. Let us start with the initial screen of Spullows, where you enter the basic information for bellows design. We start by selecting the units that needs to be entered for the design. Spullows allows you to do the design in 3 units, namely kilogram per centimeter square, mmks, and IPS, which is the imperial system. All the input and design calculations will be carried out based on the selected units. Next, we select the shape of the bellow that is to be designed, circular or rectangular. Based on this selection, the next drop down, namely the type of bellow, gets populated. In our example, we have chosen a circular bellow. So the types listed are bellows for high temperature, gimbal, hinged, etc. Similarly, if we choose rectangular bellows as the bellow shape, the bellows type drop down gets populated with double mitered corner, rounded corner, etc. Next input is the bellows kind. This drop down list again changes based on the choices made in the above 2 steps. Here, we can choose if we want to design a single or a double. Double is what is called the universal bellow. For example, for a gimbal bellow, the list gets populated as not applicable. The next input that we come across is the standard. Here, we set our preferences on designing the bellow as per EJMA or ASME standards, wherever applicable. The next set of inputs is the drawing information, where we enter some basic information on the drawing, the client, etc. This information gets printed on to the final report, and also we can use the information entered here to recall a previously completed design. This feature acts as a central repository for all your previous designs, which can be retrieved, reviewed, and edited at will. We can open the previous design for editing the old drawing or to design a new design on the same name. Clicking on the search button brings out all the designs created and stored in the folders. We can even search for the specific drawing number which we would like to view or edit. This can be achieved by entering the drawing number on the search box, and we can then select the drawing of relevance. Now let us do a design for circular bellows, normal single bellows with EJMA standards. Let me put in the basic information. Now that we have entered the basic information, we move on to the next step by clicking on the next button. This will take us to the main input screen. Here, we are prompted to enter the desired bellows parameters like geometry, temperature constraints, collar geometry, and movement values. Spullows comes preloaded with a lot of basic data like the ANSI pipe schedules, the material databases, which has the allowable stresses and modulus of elasticity and yield strength, etc., the collar dimensions, and the software allows you to add these values or modify them as you deem necessary. Spullows follows an inline method of calculation, wherein the system responds to the user's inputs by validating it and gives you a feedback on what's happening. All these messages can be seen on the right hand side of the screen. Now, let us start entering the values. First, we choose the type of manufacturing, whether you want an as-formed or an annealed type of manufacturing for the current requirement. Then, we can select the type of material. As mentioned earlier, Spullows comes preloaded with a list of 27 materials which can be added or edited as per your needs. This can be done by clicking on the button next to the materials drop-down. On the click, all the available materials are listed. To add a material, scroll down and the material is in the last row. We need to add the physical properties of the new material, which is a one-time process. Now let us start entering the values for designing our bellow. Next in the list is the nominal diameter, the design pressure, temperatures, etc. While I keep entering the data, please take note of two things that happen. Based on my inputs on the material, nominal diameter and temperature, the system automatically picks up the values for stress and the ANSI pipe schedule. These values are picked up from the user editable preloaded values in the system. At any point of time, the user can modify these values by right-clicking on the value and entering a custom value. As part of the feedback mechanism, the system lists out a set of messages that can be seen on the right-hand side of the screen. Now let's enter bellows geometry and temperature parameters. The next set of inputs needed are titled bellows geometry. Here, we will enter the ply thickness, number of plies, pitch, width, and tangent length. One interesting aspect to note here is that as part of the inputs, the system asks you for the number of convolutions. We can leave this entry as 0, and as part of the next step, the system will perform the calculations for different convolution values and lets you choose the ideal one. Spullows not only tells you about input errors, but also gives you intelligent suggestions. Let's look at this message. Q by W is less than 0.7. As part of the system configuration, this manufacturer has set a standard that the pitch to width ratio should be kept between 0.7 and 1.4. Hence, the system shows this message. Now let's quickly correct this. After correcting this, we should see the error message go away. Next, we can enter the movements and then we move on to the next screen. Once we go to the next screen, the system performs the basic bellow calculation as per the entered values, and it validates it with the checklist provided by EJMA or ASME. The screen is split into two halves, room temperature and design temperature. The room temperature column is the one that we will be looking at, as this is as per the standard. The design temperature column is for reference only. The fatigue cycle, spring rate and the weight of the bellow for each convolution is displayed so that it is easy to select the right type of bellow. Against each convolution, there is a show button. When you click on this, you will see all the intermediate calculations displayed here, and that can be verified, and it gives the facility to check if the design is passed as per EJMA. There is another way to check if the design is as per EJMA. If you see the main screen, there will be a red mark to the first convolution. This is an indicator that it has failed at least one of EJMA's criteria. Clicking on this red exclamation button details out all the criteria that has failed as per the selected standard, either EJMA or ASME. Once we decide on the number of convolutions, we choose it by clicking on the corresponding checkbox. Now, we have chosen the required number of convolutions. We need to move on to the next step of choosing the additional hardware required for this design. The hardware screen basically lets you choose hardware necessary for the design. This screen is divided into three parts. On the left hand side, the system gives you an indicative image of the bellows and any hardware that is chosen. This part gets updated in accordance with the hardware chosen. The right hand side is divided into two halves vertically. The top portion lists out the bill of material for this particular design. You can add, remove, modify a particular BOM by clicking on the modify button. The bottom part shows you error or suggestion messages. Again, Spullows is preloaded with formulas and tables which are used to suggest ideal values. For example, tie rods or limiting rods are automatically suggested by the system. Also, the flange selection can be based on 4 different standards like ASME, DIN, AWWA and IS. Any additional standards can be incorporated into the system as part of customization. Let us quickly choose some hardware and proceed on to the last step in designing the bellow. The next step is the report screen. You are presented with a summary of design parameters like pitch, width and other material properties along with the stress column values. You can scroll down and note that the report includes pass-fail criteria as per the standards chosen. This is a comprehensive and customizable report which can be saved in a HTML format, and you can choose your favorite word processor like Microsoft Word, etc. to modify the contents or format of the report. The report will also have schematic drawings of all the hardware selected with minor details like the end pipe edge preparation, the tie rod threaded length 1 and 2, and many other features, just to name a few of them. The next steps are to generate a 2D or 3D drawing of the bellows that we have just designed. Currently, Spullows supports AutoCAD for 2D drawings and SolidWorks for 3D modeling. Again, this can be customized to show the output as per the modeling tool or the drafting tool that you use, subject to feasibility. Let us see how we can generate an AutoCAD drawing first. We click on the Finish button and select an AutoCAD without PDF option. Spullows will automatically open AutoCAD, then outputs the design in a 1:1 scale and also populates the bill of materials appropriately. The title block is also filled with details that were entered in the initial screen. The basic dimensions are also displayed. This can also be customized based on the client requirements as to how they want the drawing to be generated. Similarly, a 1:1 scaled 3D model of the design can be generated by clicking on the Finish and selecting the SolidWorks option. This will open the SolidWorks application, model along with all the child parts and assembly automatically within a couple of minutes. So with this, you will have all the 3D model of the child parts, the sub-assembly of the limit rods, and the complete assembly of the bellows in a 1:1 3D model. In addition to this, Spullows also has an inbuilt costing sheet where you can define the costing for each part as per your requirements. The contents and format of this are fully customizable as per your needs. Once all the details are entered, Spullows gives you an output in Microsoft Excel format with all the pre-filled values. Hope you've enjoyed the video presentation on Spullows. Before we conclude, let us quickly list out the highlights of this product. Spullows is a fully customizable design wizard for metallic expansion joint. You can design your bellow in either EJMA or ASME standards. complete customization of formulas, messages in accordance to the individual manufacturer's specifications, ability to generate scaled 2D, 3D models with a click of a button, an ability to generate a costing sheet and a quotation based on the specifics of a design below. If you need any further details or schedule a live presentation, please feel free to get in touch with us.